Hi everyone, my name is Saeideh Arsalani. I am PhD student of Professor Antônio Adilton Carneiro and Professor do BAFA. Today I would like to talk about my PhD project with title of Multifunctional Nanoparticles for Ultrasound-guided Theranostic applications. As we know, cancer is known as one of the main causes of death all around of the world. Although some techniques such as chemotherapy and surgery were used to cure cancer, these methods have some drawbacks. Therefore, nanotechnology has been produced in order to overcome this limitation and improve the healthcare of the patients. In this regard, various nanomaterials have been proposed. Among them, mighty nanoparticles and gold nanorods are considered as the most interesting candidates in biomedical applications due to their unique properties. Here you observe the image of different materials with different sizes, and we have the view of mighty nanoparticle with appropriate size in biomedical applications. And in the right side, we have the gold nanorods presenting a great optical properties. So when nanoparticle exhibiting a great physiochemical properties, it makes them applicable to be used in theranostic application, which means both as a diagnostic and therapy. As diagnostic, I can talk about a magnetic ultrasound imaging, which is used to localize the presence of mighty nanoparticle within the tissue. And photoacoustic imaging is a combination of ultrasound imaging and optical imaging. And as therapy, I can say magnetic hyperthermia, which is one of the most effective forms of therapy to cure cancers. I should mention that all these techniques have already implemented in the GIMUS laboratory. So the purpose of this study was to produce intelligent multifunctional nanoparticle in order to generate a great performance in theranostic application. As an example here, you see the image of MMUS for a sample that using appropriate surfactant of the PEG and provide a great contrast of signal for us of MMUS, and here is presenting a where mighty nanoparticle are embedded in. Another example is when we mix a mighty nanoparticle with gold nanorod. Also, this combination provides a great contrast for MMUS. Another application, which is photoacoustic imaging for diagnostic application. Here we have the example of combination of mighty nanoparticle with gold nanorods. Interestingly, we observe for this mixing these two types of nanoparticle, we have a great signal of photoacoustic, which is suggesting that this combination can be possible for a good contrast for this modality. Lastly, as a therapy application, I should talk about magnetic hyperthermia. So when we use an appropriate sample, as an example, we use a good surfactant, we can observe that we are increasing the temperature variation over time for this sample, which is desirable for biomedical application. To sum up, I should mention we produced intelligent hybrid nanoparticle, and after doing all required characterization and obtaining great physiochemical properties, we have examined this sample in the theranostic application, and interestingly, we observed great performance both as a diagnostic and in therapy application. And lastly, I would like to thank the GIMUS laboratory for all their support and friendly environment, and also CAPS, CMPQ, and FABSB.